Good day, grade 11s. Today we will look at the inclination of a line. Okay, just a basic definition. If you incline something, you elevate or you give it a slope. So we are going to look at, so when we are finding the inclination of a line or talking about the inclination of a line, we are talking about the angle that gives the line the slope or the gradient. So it is the angle that is formed between the line and the horizontal in an anti-clockwise direction. So if you look at this diagram, this is your line like that. So the inclination is the angle at the bottom that is measured between the horizontal. This is your horizontal, and it is measured in an anti-clockwise direction like that. So it is that angle that is giving it a slope. So if this if the theta is small like that, obviously the gradient is not, or the line is not going to be very steep. If the line is very steep, the inclination also increases. So inclination is that angle that gives the line its slope. So now remember, slope is the gradient. Okay, so if you calculate the gradient of this line like we have done previously, the gradient of the line is going to be 8 minus 0. Remember, this is the origin, so origin is 0, 0. Okay, so it is 8 minus 0 and over 4 minus 0, which gives us 8 over 4, which is equal to 2. So the gradient of this line is equal to 2. Now, if we look at the triangle that has been formed, and we make use of this triangle and trigonometry that we have done before, 8 is an opposite to theta, 4 is the adjacent to theta. So that means if we are interested in finding theta, we have to use tan. Remember, SOHCAHTOA. So opposite of adjacent gives us what? Gives us tan. So tan theta is then going to be opposite of adjacent. Now if you substitute that, tan theta is going to be 8 over 4. Now if you check here, this 8 over 4 that we have found using trigonometry is the same as the 8 over 4 that we found when we were doing the gradient. So that means the inclination of a line can be found by using what? The gradient of that line. Okay, so that is what I've written here. So inclination of a line is obtained from its gradient, or we can also say the inclination gives us the gradient of a line. So it is very, very important to remember these 2 points, that if you have the inclination, you can get the gradient, or if you have the gradient, you can get the inclination. So this is just summarized in this. So if you have the gradient, you can get the theta, or if you have the theta, then you can have the gradient. It's very, very important to remember this, because we are going to apply it in lessons to follow. Okay, so remember, now to find theta, we have to now take the inverse of that. We're taking tan to the other side, remember, like we did in trigonometry. So it becomes tan inverse of the gradient that you have over there. Okay, so if the gradient is positive, the theta is going to be, or the inclination is going to be acute. So now you see how I've placed it. The line can be anywhere. It doesn't have to be all or in touch with the origin all the time. So as long as the gradient, you can see the line is increasing like that. So the gradient is positive, so the inclination is going to be an acute angle. And now, as you can see there, I can place the horizontal anywhere. It doesn't have to be always attached to the x-axis. So I can place it over there. And remember, if this is my horizontal, it's obviously going to be parallel to the x-axis. So if it is parallel to the x-axis, it means this is a corresponding angle to that, and corresponding angles are equal. So so that is what so you can place the horizontal anywhere, as long as you can make sure that it is parallel to the x-axis. Okay, and then also here, if the gradient is negative, theta is going to be obtuse. Okay, the gradient is negative, theta is going to be obtuse. So that means it is in the second quadrant. And remember, in the second quadrant, is 180 minus theta. So that means we need a theta that is in the first quadrant. So this is what I wrote here. Remember that if the gradient is negative, then it means we have to first calculate a reference angle that is in the first quadrant for us to be able to then find what that obtuse angle is going to be. You'll see when we do examples. So again, as you can see, the theta can be, as long as it is measured in an anti-clockwise direction with the horizontal. So my horizontal here is the x-axis, or I can have my horizontal down there, or I could have had my horizontal up here. So it doesn't matter where you place the horizontal to measure. So I'm trying, and as if you can remember, the gradient of the line is the same throughout. So it doesn't matter even if I measure my theta over here or there or there, the gradient of the line is the same throughout. All right. And then I just wanted to emphasize this, that because we are dealing with only acute and obtuse angles, we only work in first and second quadrant. In case you are wondering why we are now not including the third and the fourth quadrant, it's because we are only dealing with the acute and obtuse angles. So it's angles between 0 and 180 degrees only. Okay. So the inclination is sometimes called the angle of inclination. So sometimes you'll find a question saying inclination, or sometimes it will say angle of inclination, right? So let's look at a few examples. Calculate the inclination of a line that passes through -5 and 2, -5, 5 and 2, -4. So the first thing that we are looking for the inclination. So before we find the inclination, we need to know the gradient. So the gradient of the line calculated is going to be -9/7. Leave it as a fraction, don't change it to a decimal. Okay, so that means this is negative. It means we need to first find, okay, we write this, tan theta is equals to -9/7. Okay, so because we said what? Because we said tan theta is equals to the gradient, so we make use of this all the time. Okay, so now because this is negative, it means we need the reference, so we find the reference to be 52.13. Now remember, if this is negative, if the gradient is negative, we are expecting a value that is obtuse. So that means we have to subtract this one from 180. So that's what I did. I got 127.87, which is as expected because the gradient is negative. All right, example 2. Now the line, as you can see, it's increasing. So I'm expecting my theta to be an acute angle. So I've just written here that, as you can see, theta is placed there by the x-axis. And then the points that they've given us are right there at the ends. So remember, the gradient is the same throughout, so it doesn't matter where theta is, as long as it is measured on the horizontal. The gradient is the same throughout, so you use the gradient of the line. Okay, so the gradient of the line is 4/5, and then tan theta is going to be 4/5, and then theta is going to be 38.66 as expected. Now find the inclination of a line defined by 2y plus x equals to 4. Now they don't give us coordinates, but if they've given us the equation of the line, it means we can be able to fix this and find what? The gradient. Okay, so if I fix this x to the other side, it becomes -x plus 4. Please remember, when you fix this, the x term must be must start first, because remember we're writing it as y is equals to mx plus c. So it must come first before the constant. Right, we divide by 2, so, and then after that we can say that m is equal, or the gradient is equals to -1. So that means tan theta, the inclination, is then going to be -1/2. So again, because this is negative, it means we have to find a reference angle first, which was 26.57. Therefore theta is going to be 153.43. So it's very, very important that you remember that if the gradient is negative, you first have to find the reference angle before you can find the actual inclination. All right, and then the last example, calculate the gradient of a line. Now remember what I said, you can get the gradient if you are given theta, or you can get theta if you are given the gradient. So now we have been given theta, and now we must find the gradient. So you just use your calculator. Remember, tan theta is equals to the gradient. Okay, so tan, our theta here is 135. So you just use your calculator. Tan 135 will give you -1. So the gradient of this line would be -1. Then if you're asked to find the equation, then you can work with that, but we'll do that later. Okay, so please do exercise 3 as defined here. Thank you.